I want to start today looking at significant figures. This is something that is very important in chemistry. You will be calculating a lot of things and you'll need to report all of your answers with the correct number of digits. The numbers that we report in chemistry are limited to whatever type of measuring tool that we're using. For instance, a graduated cylinder would be able to measure a more detailed amount of water, for example, than a beaker. Different measuring tools are just limited on what they can report. And so we need to have a set of rules for how many significant digits we need to have in our answer. Our first rule is that all non-zero digits, so if we're looking at our non-zero digits in this example, we have 4 non-zeros, and so our significant digits are 4. In our next example, we have 5.6. 2 numbers, so 2 significant digits. Take a look at these last two. Pause it if you need to. See if you can figure out how many significant digits there are, and then start it back up and check and make sure that you are correct. £65.6 pounds would have 3 significant digits, and this 122.55 meters has a total of 5. Rule number 2. All zeros between non-zero digits are significant. So if we have zeros, which we will have, we need to know whether the zero counts or not. So the rest of our rules are going to kind of deal with zeros. If it's between 2 non-zeros, then they do count. So here we have 50.8 millimeters. So the 0 between the 5 and the 8 counts, so that we have 3 significant digits. In our second example, 2001 minutes, those would have, those zeros are between 2 significant numbers, and so we have total of 4 significant digits. 101 pounds. We have a 0 between 2 ones, and so that would be 3 significant digits. Try this last one. Hopefully you said 3, because that 0 is between 2 non-zero numbers, and so all of those numbers count. Rule number 3 also deals with zeros, only now we're looking at zeros that are at the beginning of a number. We have this frequently when we have really small numbers. We have these zeros that are at the beginning, and those are not going to count. So in this case, just the 8 counts as 1 significant digit. Here in our second example, again, these beginning zeros do not count, so it's just the 1, the 5, and the 6, so we have a total of 3. Take a look at this one, 0.0402 pounds. We know that these zeros in the front don't count, but our last rule just said that all zeros between non-zero digits count. So this 0 does, so we have a total of 3 significant digits. And then take a look at your last example. How many significant digits do you have? Remember, the ones in the front don't count, so hopefully you said 3. Just the 2, the 6, and the 2. Our last rule deals with trailing zeros. What do we do with the zeros that are behind numbers? This one depends on our decimal point. Ending zeros are significant and we need to count them if the decimal point is written. But if there is no decimal point written, then zeros at the end of our number do not count. So in our first example, we have zeros that are trailing. They're at the end of our number, and so our rule says it depends on our decimal point. We do have a decimal point, and so our total would be 5. Here, when we have 100 grams, there's no decimal point. So these zeros that are at the end do not count. So we would just report 1 significant digit. I know it doesn't look like much of a difference, but that decimal point says that we were accurately able to measure 100 liters. And so that decimal point makes these ending zeros count. And so here we have 3. Try this last example. Remember that trailing zeros depend on the decimal point. Is there a decimal point? If there's not, then you need to make sure that you're only counting the zeros that follow. If there's not a decimal point, then you need to make sure you're only counting the zeros that follow our other rules. So these zeros at the end do not count. However, the 0 in the middle does because it is between two non-zero numbers. So again, we only have 3. Now we're going to be using significant digits a lot, like I mentioned, and we're going to be measuring a lot of different objects. And so we need to know how significant digits play a part in measuring objects. So for example, let's say that this is a piece of yarn, a piece of metal, whatever it is, and we need to know what the length of it is. So here's our ruler, and we know that it's measured in centimeters, and we need to report what the length of this is. Now we know that it's somewhere between 2 and 3, and some people might just round up and say, oh, this is 3 centimeters. That really wouldn't be very accurate since it's not actually 3 centimeters. So we know that it is definitely somewhere between 2 and 3, but it's not quite 3. So our first digit is just going to be 2 centimeters. And we know that. We know that digit just based off of the ruler, and we can see that it's definitely more than 2 centimeters. And then we want to narrow it down even further. So if you take a look, these are 0.1, so 2.1, 2.2, 2.3. So right here we're at 2.7 and 2.8. We're not quite at 2.8 if we're looking at this really carefully. So we know that we're somewhere between 2.7 and 2.8. We can definitely say that right now we have 2.7 centimeters, but it's a little bit more than 2.7. And so we are going to estimate our third digit here, and you could say maybe 2.75, 2.76, 2.77. It's somewhere between the 0.7 and the 0.8. So this third digit is estimated. It's going to be different. Maybe even the person sitting beside you might have their answer might be a little different, but they're going to be very, very close. The 2 and the 0.7 should be the same. It's that estimated digit that might differ. As the measurer, you are always going to read one place beyond what your tool allows you to. So in this ruler, because it does the 10th place, and we can do the decimal, we can go one beyond that. We can actually go to the 100th place. So you always want to go one place beyond what your piece of equipment can actually measure. All 3 of these numbers are significant. If we ended by saying that we had 2.77 centimeters, that would be fine. We would still need to report that this had 3 significant digits. Now, in science, we're always doing calculations, and addition and subtraction is definitely something that we will be doing in this class. So we need to know how we calculate significant digits when we're adding or subtracting numbers. When you're adding or subtracting, the rule is the same. Your answer should have as many decimal places as the measurement with the fewest decimal places. So for example, if we have 25.2, which only has 1 decimal place, and we're adding to that 1.34, which has 2 decimal places, our rule says that our answer can only have 1 decimal place. It has to have the number of the fewest in our problem. So when we add that up, we would get 26.54, but that's not the answer you would want to report to me or put in a lab. You would want to say 26.5. we would only want the 1 decimal place to be able to follow this rule. Let's do this one, 58.925 minus 18.2. First of all, you need to think about how many significant digits are in, or how many decimal places are in each of the examples. So this one has 3 decimal places, and your second example, the 18.2, only has 1 decimal place. So our rule again says that we can only report our answer with the fewest number of decimal places. When we calculate this out, we get 40.725. That can't be the answer that you actually record, though, since we're only allowed 1 decimal place. That 2 doesn't round it up, so 40.7 would just be your final answer. I want you to give this one a try, and go ahead and pause the video, and you can use a calculator if you want. You don't have to, it's up to you, but pause the video, give yourself time to calculate this one out, and then push play and make sure that your answer is correct before you move on. Alright, if you're back with me, it means that hopefully you've already worked this problem out, and you've realized that these 2 problems both end in 1 decimal place, and this one has 2 decimal places. So in our final answer, the 256.75, if we were to calculate this out, we're only allowed to record 1 decimal place. So if that's where our stopping point is, we still need to round correctly. So we would always look at the next number over, in this case 5. 5 or higher, round your number up. So 256.8 should be what you have for your reported answer. If we look at multiplying and dividing, the rule is different. In this case, we need to look at the total number of significant digits, not just the number of decimal places. So we're going to want to round or add zeros if we need to until we have the same number of significant digits as whichever number has the fewest. For example, 2.19 times 4.2. This first one has a total of 3 significant digits. Again, we're not looking at the decimal places when we multiply or divide. 4.2 has 2 total significant figures or digits. So when you do your answer, 9.198, you're only allowed in your reported answer to have 2 significant digits because that's the lowest amount. So that 9.198, we only want 2 significant digits. So we're going to stop at the 1. Again, we need to round properly. So that 9 is going to round up, and so our actual answer is 9.2. We just want the 2 significant digits in our final answer. Let's work through a division problem. In this case, 4.311 divided by 0.07. Think back to your rules of significant digits. This one has 4. This one only has 1. Beginning zeros do not count. So when we calculate this out, we get a really long answer, 61.5857. We don't even care what all this is. We know that we don't need that many digits in our reported answer. We know that we're only allowed to have 1. That's our lowest. So we're only allowed to keep the 6. Now we need to look at this, the next number. That 1 doesn't round it up. It's going to keep our number the same. But 6 wouldn't be a good answer because that's nowhere near what our actual calculated answer is. We would want to leave it as 60. So we need that 0 as a placeholder. But remember our rule that says if there's no decimal place present, then the trailing zeros don't count. So do not put a decimal, just 60. And then we only have the 1 significant digit from the 6. Try this next one on your own. Make sure that you do your multiplication first, and then you do your division last. Pause the video if you need to, and then replay it to double check your answer. Alright, if you're back with me, it means that you've calculated this one out and you know that your reported answer should only have 3 significant digits. And that would be because we have 4 significant here The 301 has 3 significant digits, and the 5.90 has 3 significant digits. Remember, trailing zeros count when there is a decimal place. So if we multiply the 56.34 times 301 and we divide by 5.90, we are going to get, try that again, we're going to get 2,874.294915. We're not even going to use all those numbers because we're only allowed to report 3 significant digits. So 1, 2, 3. We're going to have to stop at that 7. Again, we want to look at our next number for rounding. It's going to keep it the same, so 2,870. We still need to keep a 0 there as a placeholder, because when you multiply and divide here, you do not get 287. We can't just drop that number and expect it to be correct. So we sometimes need to add zeros as a placeholder, and in this case we need to do that. But no decimal place. If there was a decimal place, then this would have 4 significant digits, which would be too many. So sometimes you're not going to be drawing in your decimal point, and other times you will. It really needs to depend on that rule.